it sounded to me like Gibbs was taking a very practical point of view and simply saying that when you do the counting as if the particles were indistinguishable, then you get an entity that behaves in an additive way, the right way. But he didn't seem to be making at all a metaphysical point. He particularly emphasized the importance of practical considerations in coming up with an appropriate entropy formula. But in any case, it's so. In any case, the bottom line is that you don't. Insofar as Tim and I would be concerned, is that there's no need. The fact that you have, even if you have to regard particles as indistinguishable, and if they're identical particles, it's sort of natural to do so, unlabeled, as Tim was describing. That's just as true classically as quantum mechanically. The fact that you can follow trajectories to the contrary, the usual argument, as absolutely notwithstanding it, if you think about it, it just doesn't play any role whatsoever in to argue, to support the invalidity of this point of view.
May I add something, Sherry? Just a small comment. Because you were talking about the relevance of mathematical structures, I want to point out that this structure here, people know that it's the right structure. And I'm talking to James that is liking structures. Because when you are in 2 dimensions, if you are a sort of physical, now they have a lot of 2-dimensional solid matter, and they discover anyons. Mm-hmm. Now, if you are in the spirit of permutations, whatever, you don't get that. But if you really think that the right structure behind everything is this one, that means it's the relationship between the true configuration space, which is the set of all sets of pairs of points in physical space. And then due to the topology, then you go to the configuration, to the covering space. If the physical space is 2-dimensional, the covering group is not, the covering space, the fundamental group of the covering space is not anymore the permutation group, but is the braid group. Mm-hmm. And you get all the anyons statistic, that means you get much more, what people think is the right structure, the right quantum structure. But people usually got all these working and thinking in terms of path integral, where you have some sort of virtual particles, so some sort of virtual trajectories. The value of Bohm mechanics is that everything fits together nicely. That means you have a clear understanding why you should look at that space, because of the velocity vector field is defined by wave function that are living on all the covering space.
So going back to what you said, so when, just to relate this to what you said in my talk, so I said, oh yeah, well in Bohm theory, I just gave a naive thing about that. So of course none of this is all moot in Bohm theory because they're individuated by the trajectories, so they're absolutely distinguishable. And you said that's got nothing to do with it, right? Yeah. So your point was then that we didn't have to say anything about trajectories here. We just have one particle, another particle, and there are different points. It's not the trajectories, it's just that synchronically they're distinct because one's here and one's there.
Yeah. Yeah.
So, and so the physicist who was here, who's
Sean or Gerald Golden.
Yeah. So he also said, well, look, you know, what are you saying this for? Because one particle's here and one particle's there. Yeah. So the bottom, there's the even bottomer line is even more subterranean line that the philosophical discussion about this is sort of unstable because it's taking place in the wrong domain, because it's not dealing with a clear ontology of particles. It's looking at ordinary quantum mechanics, taking it at face value, and then saying, okay, if in the language of that theory we can predicate the same properties of these different particles, as we get into this fussing about them being absolutely indiscernible. So they're not absolutely discernible, and we say they're weakly discernible because they've got opposite, because they're anti-symmetrized or whatever. And you would say that isn't really a stable place to have this discussion. That one should either one should deal with a proper understanding of what the particles are, or stop talking about them as particles altogether, or something.
Yeah, I would say philosophical problems are rather subtle problems, and they shouldn't usually, and it's kind of dangerous to engage in them when you're talking where they're hard enough. They should be hard enough when the ontology is perfectly clear, apart from the philosophical issues.
Right.
If the ontology is utterly vague without them, then you're in danger.
So I think
about
you go for
going up.
some. So I think you go for some epistemic interpretation of the quantum state, and then who cares if they're indistinguishable, because that's just epistemic indistinguishability, or you think about them ontologically, and then this is the right picture, and then they're absolutely distinguishable.
Right, or whatever your ontology is. I mean, I would begin, one way to understand is to say, what do you mean when you say the particles are indistinguishable? And one thing you may say is, what I mean is, there is no physical difference between the permuted states.
Yeah.
Right? So that tells you at the beginning, if on the mathematical side,
Right.
there's a permutation operator that takes you from one mathematical object to a distinct mathematical object, you already know your mathematics is not lined up with your ontology in the right
Yeah.
way, and you're probably going to end up with a hell of a mess,
But
or you're going to have to put some
that-
other constraints on. The right way to solve it is not to let the problem in at the beginning and then try and kill it off later by adding, oh, it's got to be symmetrized or anti-symmetrized. The elegant way to, and this is why I'm so impressed by this, the elegant way to do it is to avoid it in the first place.
Right.
By saying, I just don't have distinct mathematical representations that, as it were, you apply a permutation operator to one and you get a different one.
Yeah.
Right? And then the whole problem never arises in the first place.
And it does make it a little bit difficult to do certain computations, to write equations down maybe a little
Right.
bit. But actually, conceptually, you could well appreciate that it really makes, if you can't think too far ahead, your brain is a little limited, like mine is. You really find that having something which is avoids unnecessary complications, like using the right representation, the simplest representation, a more isomorphic representation of the actual situation, really makes it a lot easier to think about, to do some sort of conceptual analysis, even from the point of view of mathematics.
Right. So we have to be careful when we say there's no physical difference between the permuted states, because that someone might hear that and say,
No,
what you mean
there's
is
only
they're
one
not the
state.
same. You mean, yeah.
I mean, there's
no
only
local
one state.
difference, or
Right.
That's a crucial thing.
There's only one such
And
state.
so we don't.
You don't have a pair of states.
Yeah.
Right?
we don't have states.
Maybe somebody's made this, they must have made this point already. If you think you're in a situation which has lots of deep symmetry, you're probably better off changing the description of situation so that symmetry doesn't act anymore.
Look, that's been taken too far. I mean, people
That
have
could
said that,
go
but it
too
can be
far.
taken too
Oh,
far because
yeah.
there might be symmetrical physical objects, like Euclidean space. And this is this whole constrained Hamiltonian formalism stuff where you sort of formally gauge out all these degrees of freedom. And I think you get rid of too much.
Now,
and that can end up with
I don't know,
problems.
Julie
But
and Barbara
you have to think about
probably
which
does that.
symmetries are physical and which aren't
Yeah,
symmetrical. which are not
but
physical.
it's a question of how far you go, and it's a question of how deeply symmetrical you think the situation is.
Okay, thank you very much.
So can I suggest that we stop? So we get home.
Yeah.
And thanks a lot for everybody.
And thank you, Pat.
And everybody can fill their pockets. So.
Also, if anybody has receipts left